Hello, my name is Asya Mitseva, and I will present our work on website of fingerprinting. So our work focuses on the Tor network, which is the most popular low latency anonymization network nowadays. And one of the main goals of the Tor network is to provide linkability, which means that a local attacker who is located between the Tor network and the Tor user cannot know both the IP address of the Tor user and its final destination. However, previous work has shown that Tor is vulnerable to website fingerprinting. What is website fingerprinting? In this case, a local attacker tries to identify which website has been visited by the user without breaking the encryption and relaying just on a network level metadata such as packet sizes, direction, and timing. And previous work has shown that this attack can achieve very high accuracy in laboratory settings. Despite this high accuracy, this attack, the scalability of the attack is still under research, and typically previous work focuses only on the detection of isolated web page loads. However, users often visit multiple pages of the same website sequentially, for instance, by following links. Therefore, we are proposing a new evaluation setting where we consider consecutive users' visits of multiple pages of the same website, and our goal is to detect the whole website, not isolated web pages. Based on our new evaluation setting, we are also analyzing what is the suitability of the previous state-of-the-art web page classifiers for website fingerprinting, and we show that their accuracy decreases by 20 to 30% for website fingerprinting. We further propose novel fingerprinting strategies for our new evaluation setting. First, we are using 6 different voting-based fingerprinting strategies in order to boost existing web page classifiers. And second, we propose new set-aware classifier which is based on a new branch in the machine learning called multi-instance learning. And finally, we show that when we use our novel strategies, existing website fingerprinting defenses have only limited protection. So let me give some insights for our fingerprinting strategies. For our voting-based strategies, we train one web page classifier on multiple pages of the same website, and we compute probability of a single page that belong to this website. And finally, we are calculating a joint probability for the pages belonging to the same website. So whether a sequence of pages belongs to this website or not. Then next, our set-aware classifier based on the multi-instance learning consists of three main steps. So first we have feature extractor, which is based on adapted CNN network. Then the feature vectors obtained from the feature extractor are grouped into bags for each website. And these bags are used in order to learn a classification model in order to predict labels of the bags and not single pages. And for this, we have adaptive learning of weights for the single pages in each bag. All right, so in order to evaluate our fingerprinting techniques, we are using a data set which consists of 100 websites, and for each of these websites we have 90 different pages. We use 4 state-of-the-art web page classifiers for the voting-based strategies, and for all experiments we use tenfold cross-validation. For our evaluation in the laboratory settings, we can say that we achieve increase in the accuracy by almost 30 to 40% for both our voting-based strategies and our set-aware classifier when users browse consecutively multiple pages. We further analyzed different training tactics. Here I will give you some insights, but please check our paper for further details. So for our voting-based strategies, we need approximately 70 training pages in order to obtain high accuracy. And for our set-aware multiple instance learning based classifier, we need only 2 training bags in order to achieve over 90% accuracy when 4 pages are visited consecutively. In case of real-world evaluation, here we use 5,000 unmonitored websites, and we see that our methods can achieve F1 score of 1 for more than half of the websites when the user visits 3 consecutive pages of a single website. Finally, we also evaluated our methods against website fingerprinting defenses. Here we see that with our methods we can achieve increase of the detection rate up to 5 times. And in the second, so the last three defenses in the table represent defenses with low implementation overhead, and exactly for these defenses we can see that they almost do not provide any protection. So we can sum up that website fingerprinting is still privacy threat for the Tor users, especially those that browse multiple pages of the website sequentially. For this, we propose different strategies using implicit knowledge of user behavior. And one remark here, our methods do not need explicit order of the visited pages. We show that as more consecutive pages have been visited, as higher is the accuracy of the attack. And finally, we show that we can achieve a significant reduction in the protection of the existing website fingerprinting defenses. If you want, you can check our paper for any further details, and I will be happy to answer your questions.